Footprinting concepts. Footprinting is the first phase of any ethical hacking or penetration testing engagement. It's like a scout meticulously mapping out enemy territory before a mission, gathering every possible piece of public information about a target organization. The primary goal of footprinting is to collect data that can be used to identify vulnerabilities, develop attack vectors, and build a comprehensive profile of the target's security posture. This can involve passive information gathering, where you don't directly interact with the target, or active methods that might involve some level of direct engagement. Key information sought includes network ranges, domain names, employee details, public-facing applications, and even financial data. Think of it as putting together a puzzle where each piece, no matter how small, contributes to the overall picture. This foundational step is crucial because the more information an attacker has, the higher the chances of a successful exploit. For defenders, understanding footprinting helps them identify what information is publicly available about their own organization, allowing them to better secure it. Footprinting through search engines. Search engines like Google, Bing, or DuckDuckGo are incredibly powerful tools for gathering open-source intelligence. It's like having an enormous public library at your fingertips, where you can find documents, forgotten web pages, or even misconfigured servers by simply knowing the right keywords. Attackers use specific search queries, known as Google dorks, to unearth sensitive information that organizations might inadvertently expose. This can include confidential documents, employee directories, login portals, or even error messages that reveal underlying system details. The beauty of this method is its complete passivity. You're simply using publicly available information. The process involves combining operators like cite, file type, enull, or entitle with keywords to narrow down searches and pinpoint relevant data. For example, you might search for a specific document type within a target's domain, revealing internal reports or old policies. This technique is effective because many organizations overlook the vast amount of data indexed by search engines. It's a goldmine for an attacker looking for low-hanging fruit or initial points of entry. Now, practically, let's see how Google Dorks can reveal hidden files. We'll use Google's search bar, a widely accessible web-based tool. To do this, we type a specific query, cite, example.com file type, PDF confidential. This instructs Google to search only within example.com for PDF files containing the word confidential. The result? We see several PDF documents, such as Confidential Report or Project Omega Docs, directly exposed in the search results. This step is crucial. It shows how easily sensitive internal documents can be discovered if not properly secured or excluded from search engine indexing. Attackers can leverage this to gain valuable insights without ever directly interacting with the target's servers. Footprinting through social networking sites. Social networking sites like LinkedIn, Facebook, and X, formerly Twitter, are treasure troves of information for footprinting. It's like observing people in a busy public square, where their conversations and shared details can inadvertently reveal critical information about their organization. Attackers leverage these platforms to gather details about employees, organizational structure, internal projects, technologies used, and even personal habits that could be exploited through social engineering. For instance, an employee's public resume on LinkedIn might list specific software skills, giving an attacker clues about the company's tech stack. The process involves searching for employees, identifying their roles, understanding reporting structures, and looking for any shared posts or discussions that might inadvertently leak sensitive operational details. Even seemingly innocuous photos can reveal office layouts or equipment. This method is highly effective because individuals often share more information than they realize, making them unwitting sources for an attacker's reconnaissance efforts. Now, practically, let's see how LinkedIn can provide organizational details. We'll use LinkedIn, a popular web-based professional networking site. To do this, we navigate to the search bar and type company, example corp, employee, then filter by people. This instructs LinkedIn to show us profiles of individuals who work at Example Corp. The result? We see a list of employees from Example Corp, including their names, titles like Senior Developer, HR Manager, and Network Engineer. This step is crucial. It reveals employee names, their roles, and even connections, which can be used to map out the organizational hierarchy or identify potential targets for phishing and social engineering attacks. Attackers gain valuable insights into who works where and what their responsibilities are. Website footprinting. Website footprinting involves methodically analyzing a target's website to gather intelligence. It's like carefully examining every room and blueprint of a building to understand its structure, security measures, and hidden passages. Attackers scrutinize every element of a website, from its source code and directory structure to its error messages and meta information. This can reveal server types, content management systems, programming languages, hidden directories, outdated plugins, and even developer comments that might expose vulnerabilities. Techniques include analyzing the robots.txt file for disallowed directories, examining HTML comments for sensitive data, identifying technologies through browser extensions, and checking for common vulnerability patterns. Even the favicon can sometimes reveal the underlying technology. This process is critical because a website is often the most public face of an organization, and even small misconfigurations can provide significant entry points for an attacker. Now, practically, let's see how we can mirror a website for offline analysis. We'll use HT-Track, a versatile tool available both as a command line and GUI application. To do this, we type HTTrack http://example.com/path/to/save. This command instructs HT-Track to download the entire example.com website to a specified local directory for offline analysis. The result? HT-Track confirms it's mirroring http://example.com and has saved the content, indicating the number of files and images copied. This step is crucial. It allows attackers to analyze the website thoroughly without directly interacting with the live server, reducing their digital footprint. They can comb through every page, script, and image at their leisure to uncover hidden directories, forgotten files, or vulnerable configurations. Email footprinting. Email footprinting involves analyzing email headers and patterns to extract valuable information about a target. It's like being a detective examining a letter's envelope and postmark to learn about its origin, journey, and sender, even before reading the content. Attackers examine email headers to identify the sender's IP address, mail servers, sending software, and even time zones. This can reveal the underlying network infrastructure, email service providers, or geographic location of the sender. It can also help identify valid email addresses within an organization, crucial for phishing campaigns. Techniques include sending a benign email to the target and analyzing the bounced message or header of a received email, using online header analysis tools, or even leveraging email validation services. Publicly available email addresses from websites or social media are also collected. This method is effective because email is a ubiquitous communication channel, and its technical metadata often contains overlooked details that can be leveraged for further reconnaissance or direct attacks. Now, practically, let's analyze an email header to gather intelligence. We'll use an online email header analyzer, a common web-based tool. To do this, we paste the raw, full email headers into the analyzer's input field. This tool then parses the complex header information into a readable format. The result? The analysis reveals key details such as the sender's IP address, the mail server that sent the email, and possibly intermediate servers it passed through. This step is crucial. It provides attackers with network infrastructure details, potentially revealing the target's internal mail servers or the specific IP ranges associated with their email communications. This information can then be used for targeted attacks or to craft more convincing phishing emails. WHOIS footprinting. WHOIS footprinting involves querying public databases to retrieve registration details about domain names and IP addresses. It's like looking up a property's deed at a public records office to find out who owns it, their contact information, and when they acquired it. Attackers use WHOIS data to uncover critical information such as the domain owner's name, organization, contact email addresses, phone numbers, physical addresses, domain registration and expiration dates, and the associated DNS name servers. Even if some information is privatized, the registrar details and creation dates can still be valuable. The process typically involves using a WHOIS client or a web-based WHOIS lookup tool. You simply enter a domain name or IP address, and the tool queries the relevant WHOIS database to retrieve the public registration record. This method is highly effective because WHOIS databases are a standardized way to ensure accountability on the Internet, and much of this information is publicly accessible, providing a rich source of initial intelligence for attackers. Now, practically, let's perform a WHOIS lookup for a domain. We'll use the WHOIS command line tool, which is commonly available on Linux systems, or a web-based WHOIS lookup service. To do this, we type whoisexample.com. This command queries the WHOIS database for information related to example.com. The result? We see details such as the domain name, registrar, registrant name. Even if privatized, the city and country might be visible, and crucial dates like the creation and expiration dates of the domain. This step is crucial. It provides attackers with administrative and technical contact information, which can be leveraged for social engineering or to identify potential targets. It also reveals the domain's age, which can indicate its stability, and the name servers, which point to the domain's DNS infrastructure. DNS footprinting. DNS footprinting involves querying domain name system records to map an organization's network infrastructure. It's like consulting a phone book for the Internet, where you can find out the phone numbers, IP addresses for various businesses, domains and subdomains, and even their different departments. Attackers leverage DNS records to discover host names, IP addresses, mail exchange servers, and potentially internal network naming conventions. Key record types include records for IP addresses, MX records for mail servers, NS records for name servers, and SRV records for service locations. Identifying subdomains can also reveal hidden applications or test environments. Techniques range from simple lookups using tools like lookup or dig to attempting zone transfers, which, if successful, can provide a complete list of all host names and IP addresses within a domain. While zone transfers are often blocked for security reasons, attempting them can still provide clues. This method is highly effective because DNS is fundamental to Internet communication, and its publicly accessible records contain a wealth of information that can guide an attacker to potential targets within a network. Now, practically, let's perform a DNS lookup for a target domain. We'll use lookup, a command line utility available on most operating systems. To do this, we simply type lookupexample.com. This command queries our configured DNS server for the IP address associated with example.com. The result? We see the DNS server that provided the answer and, crucially, the IP address 93.184.216.34 associated with example.com. This step is crucial. It provides attackers with the IP address of the target's public web server, which is the first step in identifying entry points. Further queries can uncover mail servers, subdomains, and other network resources, building a comprehensive map of the target's online presence. Network footprinting. Network footprinting involves mapping out the target's network infrastructure, identifying live hosts, open ports, and device types. It's like a reconnaissance team surveying an area to understand its layout, access points, and defensive perimeters. Attackers aim to discover the target's IP address ranges, subnet allocations, network topology, and the presence of firewalls, routers, and other network devices. This helps them understand the target's network boundaries and potential points of entry. Techniques include using traceroute to map the path to a host, which reveals intermediate routers and gateways. Port scanning tools are also used to identify open services on hosts, providing clues about their function and potential vulnerabilities. Additionally, network scanning tools can detect live hosts within a specified IP range. This method is crucial because it provides a detailed understanding of the target's active network components, allowing attackers to focus their efforts on specific, vulnerable systems. Now, practically, let's trace the route to a target domain to understand its network path. We'll use traceroute, a command line utility available on most operating systems. To do this, we type tracerouteexample.com. This command sends packets to example.com and records the path they take, showing each router or hop along the way. The result? We see a list of IP addresses and host names representing the routers that the packets traverse from our location to example.com, along with the latency for each hop. This step is crucial. It reveals the network path and the intermediate devices involved in reaching the target, which can expose the target's network architecture and potentially identify specific network devices, their locations, or even service providers. Attackers can gain insights into firewall placements and network segmentation. Footprinting through social engineering. Footprinting through social engineering involves manipulating individuals into revealing information, often without them realizing they've done so. It's like a skilled interrogator gently extracting details from someone by building rapport and exploiting human tendencies, rather than resorting to force. Attackers might impersonate trusted individuals, such as technical support, new employees, or vendors, to gather network diagrams, credentials, or organizational policies. This can occur through phone calls, emails, or even face-to-face interactions. The goal is to exploit human psychology, trust, helpfulness, curiosity, or fear to gain access to information that wouldn't be publicly available. Techniques include pretexting, where an attacker creates a fabricated scenario to engage with the target, phishing, using deceptive emails to trick individuals, and baiting, where a malicious device is left for an unsuspecting victim to discover and use. The information gathered might seem insignificant on its own, but it can provide crucial pieces to an attacker's puzzle. This method is incredibly effective because even the most robust technical security measures can be circumvented if human vulnerabilities are successfully exploited. It highlights the importance of security awareness training for all employees. Footprinting tools. Footprinting tools automate information gathering, acting as high-tech detective kits. They range from simple command line utilities like lookup to advanced graphical applications such as Maltego, streamlining the collection and analysis of public data. Some tools focus on network intelligence, others on open-source intelligence from social media or public records. Selecting the right tool is key for specific information needs. Efficient tool usage saves time, enabling rapid target profiling for attackers and informing defensive strategies for organizations. Now, practically, let's see how a powerful OSINT tool can consolidate footprinting data. We'll use Maltego, a graphical link analysis tool for open-source intelligence. We start a new graph, add a domain entity for example.com, and run transforms like to company, to person, and to DNS name. Maltego then queries public sources and visually draws connections. The result? We see example.com linked to its DNS servers, IP addresses, identified individuals, and related companies in a clear graphical representation. This visually maps relationships, providing attackers with a holistic view of the target's digital footprint and potential attack paths. Footprinting countermeasures. Footprinting countermeasures are the defensive strategies organizations implement to minimize their publicly exposed information, thereby reducing the attacker's ability to gather intelligence. It's like a spy agency employing strict protocols to control information leaks and prevent adversaries from building a profile of their operations. The goal is to limit the attack surface by controlling what information is accessible through public channels. This includes scrutinizing website content, social media profiles, and public records to ensure sensitive data is not inadvertently exposed. Key strategies involve using privacy services for domain registrations to hide personal details in WHOIS records, implementing strict access controls on public-facing servers, and ensuring that robots.txt properly disallows indexing of sensitive directories by search engines. Organizations also need to educate employees on what not to share on social media. Regular audits of an organization's digital footprint are essential to identify and remediate information leaks. For instance, checking Google Docs regularly for your own domain can reveal hidden files. This proactive approach is critical because preventing information exposure at the reconnaissance phase can significantly increase the difficulty and cost for an attacker to launch a successful attack. It's about making the attacker's job harder right from the start.